Okay, guys, so for the next couple that we have, it's for when those collisions that stick together. So here you have that one collision where they're going towards each other, they collide, and then once they collide, they stick together. And so they move off as one object. And so you see that when they stick together, they have a combined velocity of 5 meters per second. Okay, so I'm going to help you set up this one, and then you're going to do this one all by yourself, which, like the one before it, like G, it's a collision where they stick together, but in the reverse. So for H, it's essentially a explosion, like they were saying in the lab. Okay, so I'm only going to start this one with you. I'm not going to finish it because I'm going to put it in as a multiple choice question that you can solve for in Schoology. Okay? But I'm going to set you up. So it's, remember, the momentum before equals momentum after. So just to be thorough, I'll write it out. Okay, so you're going to do the momentum of car A, which you're missing car A's velocity before they collide, plus the momentum of car B, right? Very simple. You're just going to do mass times velocity of car A. That's going to equal their total momentum afterwards. Now here's where it's just a little bit different. They stick together. So for the ones that stick together, you're going to treat them as one object. Okay? So they're moving as one. So now their total momentum is basically going to be mass of A plus mass of B, because they're now moving as one, times the velocity that they're going, right? Okay, so momentum of car A. Let's go back to before the collision. 2,000 times V. That's what we're looking for. Plus the momentum of car B. 4,000 times, oh, almost forgot it. It's pointing to the left. It's negative. Okay. Now, they move as one. They're one object. After they collide, they stick together. That means you would combine their masses and treat them like one object. So you would add their masses here. And so their mass times velocity, but they got much bigger because, well, they stuck together. And the new velocity as they move together as one is 5. And so you just simplify and solve. So I'm going to leave this one for you to do and to turn in the answer. Now, this last one I'm going to leave completely for you to do. I'll talk you through it right now just for a little bit. So the man is with his bike. The mass of the rider is 60 kilograms. The mass of the bike is 20 kilograms. The man on the bike is going 5 meters per second. So it's basically they start together, kind of like how these ended together. Well, they start together on this second one. He falls off, and then he ends up chasing his bike. So then they separate. So basically, the 60 kilogram man is now running, or he's moving at 2 meters per second, while his bike is moving at what velocity? And that's what you have to figure out. Okay? So essentially, it's very similar to this, in that they start together. It'll be like this, where you add their masses and multiply by their combined velocity, and then set that equal to their total momentums afterwards. So it's basically like an opposite of what's going on in G. Okay? So I'm going to set up the questions in Schoology for you to put your answers in there.